All right, what we are learning today, last class we learned the Pythagorean identity, right? Well, there are some other identities that we can derive basically from the Pythagorean identity, okay? So these are all of the Pythagorean identities, not just sine squared of theta plus cosine squared of theta plus equals 1. There's more that we can derive from that. So that's what we're talking about today. Let's call it the other Pythagorean identities. Can the target be able to derive all of the Pythagorean identities? All right, so last class we learned about the main Pythagorean identity, I guess you could call it, okay? So let's say the most common trigonometric identities are those involving the Pythagorean theorem. We have already learned about this identity called Pythagorean identity. There are a few other identities that can be created from the Pythagorean identity. So before we get started, let's remind ourselves of a few things that we know in trig, okay? We know in trig, the unit circle has a hypotenuse of 1, right? So when you find sine, cosine, and tangent, like the sine is always the y value because the x value that you would be finding when you find sine opposite over hypotenuse is 1 when talking about the unit circle, right? So in trig, we say that the sine of theta is equal to just the y value because the x value is 1. we know that the cosecant of theta, cosecant means adjacent over hypotenuse. The adjacent leg over the hypotenuse of the angle. Well, the adjacent leg is your value of x, right? Your hypotenuse is 1, so x divided by 1 is just x. If you're talking about any other triangle, you would have to, your hypotenuse might not be 1, right? But in the unit circle, it's just x divided by 1, which is, we just say x. And then tangent of theta, tangent is y divided by x. Well, in trig, the y values we call sine of theta, and x values we call cosine of theta. We already know all this, right? Well, then we also have the reciprocals of these. Reciprocal is when you, what's in the numerator goes in the denominator, what's in the denominator goes in the numerator, right? So for a sine of theta, the reciprocal we call cosecant of theta. So instead of sine is y, so cosecant is 1 over y, or we say 1 over sine at theta. The inverse of cosecant we call secant of theta, which if cosecant is x, secant is 1 over x, or we say 1 over cosine at theta. Cotangent of theta is the inverse of tangent, so that's either x divided by y, or we say cosine of theta divided by sine of theta. And these are things we've already learned, right? A while back, nothing new. Just wanted to remind you. All right, so we learned yesterday that the one well-known equation that we can derive from Pythagorean theorem is the Pythagorean identity. And that was sine squared plus cosine squared equals 1. That's the Pythagorean identity. Right? We learned that not last class, class before. We had an assignment over it last class. Okay. What we're going to do is use this first Pythagorean identity. So they're all of them that we're going to create, they're all called Pythagorean identities, okay? This is probably just the one used most often. So use this first Pythagorean identity to create two additional identities. So let me start by rewriting that first Pythagorean identity. Sine squared, oh, I forgot my theta. Sine squared of theta plus cosine squared of theta equals 1. So what I'm going to do is I'm going to divide my first, or divide each term by cosine squared of theta. I'm not subtracting it. If I subtract it, it's the same identity, just written in a different way, okay? So what I'm going to do is I'm going to divide each term by cosine squared of theta. Each term. Next thing I'm going to do is I'm going to simplify each term. Okay, well, what's sine squared of theta divided by cosine squared of theta? All right, hint. No, because it seems like you would, like mathematically, but do we know what sine of theta divided by cosine of theta is? As tangent, right? But if they're both squared, it'll be tangent squared of theta, correct? So sine squared of theta divided by cosine squared of theta, that's basically just tangent squared of theta. Well, what do you get when you divide the cosine squared of theta divided by the cosine squared of theta? You've got something divided by itself. What do you get? That's just 1. So we're going to add 1. It doesn't go away. A lot of y'all go, well, it cancels. Well, it doesn't turn into 0. It turns into 1, right? And that equals 1 over cosine squared of theta. Well, what's 1 over cosine of theta? Secant. So instead of 1 over cosine squared of theta, we're just going to call it, what do you think? Secant squared of theta. Let me go back over to my step 2. I said simplify each term. I'm going to say by using substitution. What we have created here is another Pythagorean identity. It's probably used second most often, okay? So we know 2 Pythagorean identities. So we created a second Pythagorean identity. Oh, God. I'm so sorry. Sorry, everybody at home. I just got a little startled. You're gonna kill me right here. What did you say? Garlic? Did you eat something? Oh, no, not me. Oh, man. I think I'm still breathing. All right, everybody cool with that? So to create the third Pythagorean identity, we're going to kind of do the same thing, but instead of dividing each term by cosine squared of theta, what do you think we're going to do? We're going to divide by sine squared of theta. So all we had to do with this lesson is just derive the other identities. So that's what we're doing. I'm showing you how we are getting all 3 Pythagorean identities. We start with the one we know, and we're creating the 2 others. That's all we have to do for this lesson, okay? When you go, if you take calculus, then you will be using these a lot more, but for this part of it, we just have to derive it, okay? So let's go back to sine squared of theta plus cosine squared of theta equals 1. I'm not usually that jumpy. I don't know why that scared me so much. Okay, over here on the side, I'm going to say if we divide by a different value, we can arrive at the third identity. So like we just said, on the previous page, we started by dividing each term by cosine squared of theta. Again, if I just subtract cosine squared of theta, that is just a different way to write this same identity. It's not changing it at all, right? It's just rearranging it. So subtracting cosine squared of theta, I'm going to have the same identity, it's just going to look different. But if I divide each term by, what do we divide now? Sine squared of theta, then the result will give me a different identity. And of course, we're not going to divide each term by 1 because that won't change anything, right? But when we divide everything by sine squared of theta or cosine squared of theta, that will change. So step 1, divide each term by sine squared of theta. And then next thing we're going to do is simplify each term. By using substitution. So say you were supposed to use all 3 identities in calculus. They don't really give you all this stuff. Like, you've got to memorize a lot. And on AP exams, I don't believe you get any formulas. So in class, they're not going to give you, especially if you take AP calculus, they're not going to give you any formulas. So say you have a quiz on using the 3 Pythagorean identities. You don't remember them. Well, you probably remember that first one. It's pretty easy. Sine squared of theta plus cosine squared of theta equals 1. So you could derive it yourself, right, if you don't remember it. All right. What is sine squared of theta divided by sine squared of theta? 1. Plus, could we substitute anything for cosine of theta divided by sine of theta? Cotangent of theta. But because these were both squared, it won't just be cotangent of theta, it will be cotangent squared of theta equals. And is there anything we could substitute for 1 over, if it was just 1 over sine of theta, what's that? Cosecant, but since it's squared, we'll, yes, substitute with cosecant squared. And that is our third identity. So we're going to make a little table that's going to have all 3 identities in it, but also different ways you could write it, like rearranged. Like I said, if I had sine squared of theta plus cosine squared of theta equals 1 and I subtracted cosine squared of theta, I would still have the same identity. It would just look different, right? So I'm going to make a little table with the identities we created, and then another way that you could see it written that might be useful to you, okay? But they mean the same thing. So I'm going to say, when working with Pythagorean identities, there are other ways to express by that I mean like rearrange these identities that might be useful. So on the left side, I'm going to put the actual Pythagorean identity. And on the right side, I'm going to put other variations. So I'll start with that main one, which was sine squared of theta plus cosine squared of theta equals 1. Of course, I'm not going to say cosine squared of theta plus sine squared of theta equals 1. That's kind of obvious adding it. So you could also write that as, if you just wanted sine squared of theta to be on one side, isolate it. If we subtract cosine squared of theta from both sides, we would have sine squared of theta equals 1 minus cosine squared of theta. Because you have the 1 on the right side, you subtract cosine squared of theta. Or if you want to isolate cosine squared of theta, we could subtract sine squared of theta, right, from both sides. So that would leave us with cosine squared of theta equals 1 minus sine squared of theta. Those mean the same thing. I haven't changed them at all. I've just rearranged them. Right on? Now let's take that second one we found, which was tangent squared at theta plus 1 equals secant squared at theta. So in this one, the secant's isolated, right? Well, what if I wanted to rearrange it so that tangent was isolated? Wouldn't I just subtract 1 from both sides? So this is the same thing as tangent squared of theta equals secant squared of theta minus 1, because I'd subtract that 1 from both sides. So y'all know, a lot of times having one variable isolated, having the formula when that variable is isolated, compared to rearranging it where a different variable is isolated depending on the information that you've been given, right? So that's all we're doing here. And then that third one, and all three of these are Pythagorean identities, was 1 plus cotangent squared of theta. That equals cosecant squared of theta. So how we have it written now, cosecant's isolated. Well, what if I wanted cotangent to be isolated? Cool, we just got to get rid of this 1. How would we do it? Subtract it. So I want cotangent squared of theta to be isolated. Subtract that 1, and that's either -1 plus cosecant squared of theta or cosecant squared of theta minus 1. Either way, same thing. Coolio? Anybody confused? Have a question? Comment? Concern? So for our purposes here in pre-calculus, we needed to make sure that we could use, that we know and can use that first one, sine squared of theta plus cosine squared of theta equals 1, to find other trig ratios, right? Cosine, sine, I could use it to find tangent, and really cosecant, secant, cotangent, because I know sine and cosine, I can find all those others, right? But these others are useful depending on what you know and what you're trying to find. So all we have to do is be able to derive these other Pythagorean identities, but really be able to use that first one. That's the one you're going to see most often. Okay? So I'm not giving you an assignment over this. This was our lesson for today. As long as you have the notes, you're good to go. As usual, we're way ahead of my other pre-calculus class. I see you every day, right? 5 hours a week. And so we're going to use the rest of the class time. If you owe me something, work on it. Please get it turned in. If you still owe me something from the sub, please get it turned in. Those of you at home, I have several of you who have missing assignments. Please use this time now to get those completed and submitted on Schoology. Okay, and then y'all can log off, work on that. Everybody at home, we'll see you tomorrow. And everybody here, you know what's up? Okay. So at home, y'all can log off. Get your stuff done.
Bye, Miss Rayleigh. Hope